In this video, I'm going to show you how to use Graspable math to simplify polynomials. So polynomials are expressions that have variables and numerical values in them. So I'm going to first start by creating an expression that I'm going to simplify. So there's my math expression. Let's start with an easy one. X plus 2. I'm just using my keypad here to type this in really quickly. Y plus 5. I'm missing a bracket here. Plus 5 plus. So it inserts whatever you've typed in sort of this hand printing style, which I like. And if you're using it in a classroom and projecting it, it's big enough to be clearly readable. Okay, so part of what's fun about Graspable math is that you can rearrange objects on the surface there, and it won't allow you to do anything that's algebraically incorrect. It may rearrange things in a way that is maybe unexpected, and those are kind of teachable moments that allow you to talk about how certain expressions are equivalent, even though they may not look like the same thing at first glance. Okay, so in this case, x plus 2, these brackets here are not changing the value of what's inside them. They don't have an impact. So I can just click on those and they will disappear. And then it says add y plus 5 to that. And again, I have a set of brackets, but because it's a simple addition, the brackets aren't doing anything to those values inside. So I'm going to also click that. And then I have another one, which is a trinomial, x plus y plus 3. And I'm just adding one group of x plus y plus 3. So again, the brackets are not doing anything to this other than keeping them as a group of 3. So I'll get rid of that. So now I have this sort of alphabet soup. I'm going to move on to this point, grouping or rearranging the objects so that they're like objects together. So I can take this x that's here and just drag it over next to this other x. And it sort of shuffles everything down the line. I'll move the 2 over with the 3 and the 5 over with the 3. So now I've got all my x's together, all my y's together, and all of my constant terms together. And then if I want to combine things, I click on the operation in between them and it will do that operation, it will perform that operation. So 2 plus 5 combines to make 7, 3 plus 7 combines to make 10. If I try to do an operation like y plus 10, it's going to say no. It's going to do this little jiggle thing that tells you that that's not something that can be simplified. You can't do that operation. I can do y plus y, and I can do x plus x. And that is the simplified version of that polynomial. We'll get into factoring in a moment. So it's guessing what I want to do right now. Now, one thing that I like about this particular app or program is that currently what I have is my final step that's visible. And you'll see when I'm away from it with my mouse, you see nothing on the screen. When I go close, you have this sort of double circle thing. That tells you that I can expand that and show the steps of my process. So I can drag that out and say, okay, here were the steps that I followed to get from the question that I started with to the answer that I had in the end. And as a teacher, I always tell my students, you have to indicate what the question was that you were given. You have to do some working in the middle to say, some logical process that got you to the last final answer that you're providing. It's not enough to go directly from question to answer. Maybe for some students, they would say, well, I don't really need to show all of these additions one by one. I can just do 3 plus 2 plus 5 in my head. So in that case, you can drag a step up and mask just the steps you want to, like that. So that's showing the process of kind of eliminating unnecessary details, but they are there if you did want to blow it apart and take a look at it in very granular detail. Okay, let's start a new one. All right, so now we're going to do a multiplication problem. So we'll go A times A times A times A. And when I enter it in, it shows those multiplications as dots, which is fine. But when it inserts it, you'll see those dots disappear. So right away, it's showing students that there's that equivalent form. And then to see what happens here, if a student were to try and drag one A onto the other, it's not going to give them 2A, it's going to give them A squared, because that's what that's equivalent to. So it's a good learning tool for students to see A cubed times A makes A to the power 4. And again, when you drag down, you can see each step of that process, one at a time. I'm going to insert a second one here. Let's go something with this. Okay, and then same thing. The point is that students have the ability to shift the variables. You can start at the end if you like. And as long as that's mathematically sound, the program will be able to do it and will be able to produce an answer out of that move. Okay. If it's not mathematically sound or logical, then the symbols kind of dance on the page. And it's like saying, nope, try again. That doesn't work. Okay, so that's that kind. We're going to do arrange, and I'll get rid of these two just to clear up my screen here. All right, let's try one with a distribution. A plus B. Yeah, I'm just starting with small values just to make it easy. Okay, so right off the bat, that would be the question maybe that would be on the student's page that they were being assigned to do. And then knowing that this is a multiplication, they can drag it in. You'll see this interesting thing that happens right now. So that blue line that appears in front of the B and in front of the A is saying that that 2 is becoming a multiplier to both terms inside that set of brackets. It also, if I so choose, could end up behind the A and the B, but this is the default. It goes 2A plus 2B, like that. Okay, so I can drag that out and show step by step. Right, the brackets have disappeared because they're no longer doing anything. They're not changing any of the values inside. And one more. Right, so it automatically goes from right to left on the page. So it's also just a very logical sequencing when they're entering in their questions. So the 3A, students you can select an object, and then, oops, I'm zooming the wrong direction here. Depending on whether you have a mouse or a touch screen, it's a little bit different. But you could distribute the 3 and the A separately or at the same time. So I can first, see that, distribute the 3, and it automatically does that multiplication. Or if we go undo, I could bring it, I wonder if it will just go out front. No, it's automatically, okay. And then the A, let's say I put that out front as well. There we go. And then I can rearrange within each of these terms to put them in alphabetical order. So when I'm demonstrating that to students, I will talk them through that process. You know, why is it that the A squared term goes first and then the AB? And why is it that the A comes after the coefficient in both cases? You know, that understanding that that is not random, that it is actually a decided conventional way of writing polynomial expressions. And we're going to do one more, just to show you the versatility of this. And Right? And when I hit divide, it automatically turns that into a fraction, which is really nice because students sometimes forget that a division and a fraction are really the same thing. So it reminds them of that. Okay, let's put this over x and y to the 5. Okay, so in this case, you would start perhaps with dividing x squared by x. Simplifies to 1. If I were to take y to the 5 and divide it like this, it's going to create a negative exponent. So it does that automatically, and students may or may not be familiar with the reasoning of that. You can drag it back down like this to show that that's an equivalent form. Bring that x into the numerator as a multiplier, and that's another form. Or I could have started, I'll go back to the beginning here. There was my question to start with. Instead of going through that 3-step process, I could go directly take the y3 down into the denominator and turn it into y squared in 1 step. So it's a way for students who are perhaps working side by side to see that there are multiple ways that result in the same final expression, but they're both completely logical, mathematically speaking. And then again, if you drag down, you can see each of the steps that were taken. So I could sort of blow that apart like this, have that discussion in class. So this 2 minus 1 piece is very explicitly stated, even though that was sort of behind the scenes in the programming and it automatically changed x squared over x into x to the 1. It's showing that middle step that was implied. And then once the students are more familiar with it and they say, yep, I know that's what's happening here, they could drag and mask the pieces that they're comfortable with. So there we go. That's what it looks like. So that was a very quick demo of graspable math for simplifying polynomials. I hope you try it out.